Okay, so what the next lesson is transformation of log functions. So we did this for sine, we did this for trig, we did this for polynomials, and you're doing it a third time for logs. So you're literally doing the same thing 3 times in this damn course right now. This is the third time you're going to be doing transformations for a function. We did it for polynomial, we did it for trig, and now we're doing it for log functions. So do you guys think anything is going to change when it comes to these transformations? Nope, you guys are right. Everything pretty much stays the same, okay? Horizontal has to do with the x values. Vertical has to do with the y values. So this lesson should be pretty straightforward. So we said the inverse of the exponential function is the log function. So we have it in exponential form. 9 to the 1 over 2 is equal to 3, which means the log form is log 9 of 3 is equal to 1 over 2. So the log button on your calculator, that button always assumes a base of 10, okay? So the log button on a calculator represents log 10 x if there is no value of b. The base in the log function is understood to be base 10. Logs with base 10 are called common logs. So we want to evaluate these guys and then verify with our calculator. So remember, we have an x at the end, and we have a 10. So if you were to write this in exponential form, we get 10 to the x is equal to 100. So what would our x value be in this case? Two. So 10 to the x is equal to 10 to the 2, which means x is equal to 2. So our answer here is 2. The next one, we have the same thing. 10 to the x is equal to 1 over 10. What would our x value be? -1. We get 10 to the x is equal to 10 to the -1, which means x is equal to -1. And then last but not least, we have log of 1,000 of square root of 1,000. So we get 10 to the x is equal to 1,000 to the power of 1/2. And what would our x value be for this scenario? Three. But we can't just assume it's 3. We're going to have to simplify it a bit more. So we get 10x is equal to 10 to the 3 to the 1/2. So in reality, what does this simplify into? Three over 2. So you get x is equal to 3 over 2. So remember, guys, whenever there isn't a number on the base, it is always safe to assume that the base is automatically 10. So we have the transformations of the log function. This is exactly the same as trig plus the polynomial functions. Okay, so there's nothing really new to review here. So remember, A is the vertical stretch or compression. If A is negative, there's a reflection in the x-axis. Remember, K is the horizontal stretch of compression. If K is negative, it is reflected in the y-axis. D is the horizontal translation left or right. C is the vertical translation up or down. And when we do it in mapping notation, we get the equation x over k plus d and a over y and a times y plus c. So when a horizontal shift is applied, the vertical asymptote and domain are affected. So this is the only thing that's going to be different. So let me grab my calculator. Hold on. I could have sworn there was a button on your calculator that gave you log and then an X at the bottom. There should be a button like that because that you could have entered your base into that. But my calculator does not have that button. So check your guys' calculator if you guys have the log X button on your calculator. Because when you have log X, you would be able to enter your base. If I figure it out, I will tell you guys, and then I will give you that answer. So, like I was saying, when the horizontal shift is applied, the vertical asymptote and the domain are affected. The argument of the log function must always be positive, and the range of a transform log function is always XER. So let's just take a look at f of x is equal to log of x plus 7. It is horizontally shifted 7 units left. So that means the vertical asymptote also has to move it 7 units left. So the equation of the vertical asymptote is x is equal to -7. So remember, the expression in the bracket is your vertical asymptote, okay? So since the argument is x plus 7, must be positive, we also have an inequality to solve, which is x plus 7 is greater than 0. And then we move the 7 over, so we get x is greater than -7, which means the domain of the function is XER, such that x is greater than -7. So the bracket helps you to find the vertical asymptote, and it also helps you find the domain. So example 2, we want to describe the following transformations that must be applied to f of x log x to obtain each of the following functions. So the first one we have is f of x is equal to -5 log of x minus 2. So what is one of the transformations that we have? So we have a reflection in the x-axis. What is another transformation? Horizontal translation with 2 units right. And we have one more. You have a vertical stretch by a factor of 5. All right. So that is for example A. The next example we have is f of x is equal to log 3x minus 1. What is our first transformation? Horizontal compression of 1 over 3. And what is the last one? Vertical translation of 1 unit down. All right. And then we have example 3. So the parent function f of x log x has been compressed vertically by a factor of 1/2, reflected in the y-axis and horizontally translated 7 units left. We want to state the equation of the transform function, the domain and the range, and the equation of its vertical asymptote. So what would this equation look like given the transformations that are given to us? Thank you, Adam. So y is equal to 1/2 log negative x plus 7 in bracket. So remember, when we're looking at our vertical asymptote, we have to focus on this expression in the bracket. So x plus 7. So what would our vertical asymptote be if we set that expression equal to 0? X is equal to negative 7. Okay, so I want domain range. So what is the range of the vertical of a log function all the time? So what is the range going to be of a logarithmic function all of the time? Nope. That's the range is YER. Thank you, Bozola. And Jose, thank you for giving us the domain. So the domain is going to be XER such that X is greater than, well, it's not greater than 7. So for this particular case, we are going to need to factor in the negative as well. So we have negative X plus 7 is equal to 0. You have negative X minus 7 is greater than 0. Sorry. So you have negative X is greater than positive 7. And what happens when we divide an inequality by a negative number? The sign is going to flip. So we get X is less than negative 7. So our domain is XER such that X is less than negative 7. All right, so we just have 2 more examples, and then you guys are free to go. So we want to sketch the graph of y is equal to log 10x using 3 key points. So this is where you can use your calculator. So if you use the log function, so if we do log of 1 over 10, it is going to give us negative 1. If we do log of 1, it's going to be 0. And if we do log of 10, it is going to give us 1. So these are the 3 key points you guys are going to be using to help you find the transform points of the transform log function. So we have our points 1 and 0. 10 and 1, and 1 over 10 and negative 1. So 5, we want to use example 4. So the points above, I'm just going to write them down for you. So we have 1 over 10 and negative 1. We have 1 and 0. And we have 10 and 1. So we want to find the transform points. We want to state the domain and range of each function. And we want to label the equation of the asymptote on the graph. So the first one we have y is equal, or f of x is equal to negative 2 log 10 times x minus 3. So what would our mapping notation equations look like? So we have xy transforms into so x minus 3 and negative 2y. So we're going to write our points, 1 over 10 and negative 1, 1 and 0, and 10 and 1. So using mapping notation, what does the original point 10 and negative 1 turn into? Yep, so negative 2.9 and 2. And someone tell me what the next two are going to be. So what are the next two transform points going to look like? So we're going to have negative 2 and 0 and 7 and negative 2. Okay, so based off the information, what is our vertical asymptote going to be? So our vertical asymptote is x is equal to negative 3. Our domain is going to be XER, such that x is bigger than negative 3. And our range is going to be YER. So now let's just graph the transform function. So we have our asymptote. We have our points, negative 2 and 0, negative 2.9 and 2, and 7 and negative 2. So this is what f of x is equal to negative 2 log 10 of x plus 3. So is everyone good with this? Okay, and now we're going to move on to our last example. So you have f of x equal to log 10 times 1 over 2x plus 2 minus 3. So what is the first thing we need to do with this expression or this equation? I'm going to factor out the negative 1 over 2. So we get negative 1 over 2 bracket x minus 4. So what would our mapping notation look like? We have negative 2x plus 4 and y minus 3. I forgot about the minus 3 at the end. Okay, so we have our points 1 over 10, negative 1, 1 and 0, and 10 and 1. So what would our new points be? So you have 3.8 and negative 4. We have 2 and negative 3. And we have negative 16 and negative 2. So what would our vertical asymptote be? Four. So our vertical asymptote is x is equal to 4. Our domain, we have to take into account negative 1 over 2x minus 4 is greater than 0. So you're going to cross multiply. You get rid of the 2. So you get negative x minus 4 is greater than 0. You're going to factor out the negative into it. So you get negative x is greater than negative 4. And when we divide both sides by a negative, we get x is less than 4. So our domain is going to be XER such that x is less than 4, and our range is going to be YER. So we're going to draw our vertical asymptotes at x is equal to 4, and we're going to plot our points. So you have 2 and negative 3. You have negative 16 and negative 2. So this is going to be all the way down here. And then we have 3.8 and negative 4. This is f of x is equal to log 10 of negative 1 over 2x plus 4 minus 3. So is everyone finding this easy so far?